Okay. Are we live?
We are. I can hear you.
All right. Can they still hear me if I stand up?
I think so.
So folks can hear me a little better?
Mic.
Okay, great. Welcome, everyone. I missed you guys last month. I was over in North Carolina having a bank exam. Wee, fun. Yay. So, yeah, my first one, but it was actually quite interesting. Welcome to our May meetup for Seattle Rust User Group. Had somebody pop in and be like, is this for Rust? And if you don't know what SRUG means, it's not going to help you. So I'm going to change the title here, at least put Rust on the screen. Folks can see where they are. So yeah, great to be back. Yeah, lots to cover today. So for those who are new, you haven't heard me say this, but we operate under two codes of conduct. One, obviously, Bellevue City Hall's Code of Conduct, as well as the Rust Code of Conduct. Just to summarize, it basically says treat people with dignity and respect. And if you feel someone is not treating you with dignity and respect, please let them know. And if the behavior persists, then please let me know. And we'll take care of it from there. Oh, these slides are always available at slides.com. And my technology handle is U007D. You can pronounce that Curly should you wish to. So I'd like to introduce myself and folks in the group. We are really friendly and very interactive and want folks to feel comfortable, even if it's your first visit. Just by show of hands, who's here for the first time? Yeah. Oh, good. Okay.
Welcome.
So welcome, everyone. Good to see you. Okay. So my name is Brad. You can find me on most online forums, Discord, Reddit, wherever else. Even my LinkedIn profile is using that. And I started with the Commodore 64 way back in the day. And so I've always gravitated towards systems languages, as I was speaking with Mike. Was it Mike?
Yeah.
Okay, so I was speaking with Mike earlier today. And I didn't realize this until, fairly late in my career, but those were the languages I gravitated to that provided more minute control over the system, C and C++, and Rust, Pascal, things like that. So that's generally been my career, and I've always been attracted to low-level languages, assembly language as well, and very much into embedded systems development too, because that's also seeming, fun for low language. And I work at a banking startup during the day, so my day job doesn't necessarily scratch that particular itch, but we do it in Rust, so that's pretty cool. So yeah, anyone else want to introduce themselves? We'll have to. Unfortunately, we only have the one mic today rather than the remote mic the way we're working. So folks online may not be able to hear. But for the group that's here, let us know what your background is, or what you're interested in, or how you found this group, or what piqued your interest in Rust.
Let's start us off.
Yeah, go ahead. You can.
Yeah, my name is Jack. I've been coming to these for several years, and I don't know, when Rust was released in 1.0, I read some of those blog posts and then the book, and then it's never stopped doing it. But the reason that I wanted to grab the mic today, assuming I have it, is I wanted to mention that many of us know Sorensen, who's often here, often goes and gets pizza with us. He's happily not here today because he and his wife Monica had a baby last week. Baby Larkin is doing great. They are doing great. That makes me very happy.
Our newest Rustation, yes. Thanks. All right. Would anyone else like to say hi? You can do it from there. You don't have to come to the mic if you don't want to. That's fine. We're not a shy group, contrary to all appearances right now.
Sure. I'm Connor. I've been writing Rust for a couple years and going to here, I think, about a year-ish. I write Rust as a hobby, probably for research soon. Hope to make it a career.
Nice. Do you want to share anything about this, or is it too early to share anything about what you're up to? That's interesting.
It's very early. It's just hardware now.
Mm-hmm.
But I'm expecting what I would be doing is writing the embedded basis for the researchers to work on robotic stuff from. So I'm doing hardware interactions and whatnot.
Nice. Very cool. All right. How you doing? Yeah. Anyone else want to say hi?
Yeah, hi, my name is Sterling. I'm a student up at UW Bothell, like doing data center stuff. And I came to one of these events like a year plus ago, and I wasn't really doing much Rust, but since then I've done like a ton of projects in Rust. I really like the language.
Nice.
So I think coming to this event back then made me more comfortable to feel like there's actually people developing it. It's not just something on Twitter.
Yeah.
So,
It's real.
anyway,
Yeah.
thank you.
No problem. Thank you. Thank you. Oh, that's great to hear. That's great to hear. Yeah. There was something I was gonna say. Didn't come to me. All right. Anyone else? Bueller. Anyone? Bueller. All right. We have upcoming meetups. We typically meet on the third Thursday of every month, except for November and December due to the holidays. Those months will be at the second Thursday. But so these are the dates for our upcoming meetups. I always like to take a moment to thank our volunteers. The way we run the group is we try to keep the load very light on individual volunteers, say about an hour a month or less. And so if we can hit that average pretty consistently, and I think we have, I think it tends to be relatively smooth for folks to, to help out and run the club. So just want to take a moment and give all these folks a round of applause for their help and behind the scenes and running the meetup and the Discord and the AV and the audio and the backup speakers and the things that we do in order to have the club run smoothly. So thanks, everyone. We will chat here for a little bit, and then after the meeting is over, we typically go to Red Robin. How was this was RTC Red Robin last month, right? No,
It was Over Lake.
It was Over Lake?
Like usual.
Okay. And did they get mad?
We called in advance, so no.
Okay.
I don't know if we've done that today.
Okay. Well, yeah. You know what? I might just change. Any objections to trying RTC today?
No objection.
Redmond Town Center? Yeah, for those who know where that is. Let's just try that, and then I don't have to get on the horn with a grumpy person. Geez, how do I get to edit mode? I can draw on my slides.
Just great RTC.
Yeah, I think.
Take a marker to the wall.
Yeah. And this is not the address. So normally we meet at the Over Lake Red Robin, which is, I was going to say near where the Sears used to be, near Microsoft main campus. But we used to meet when we used to meet on Microsoft main campus. We would meet at the Redmond Town Center Red Robin, and they seem to have no problem taking our group coming in and whatever. The Over Lake people have been grumpy about it. I think they just want to go home. And so let's see if Redmond Town Center tonight is a little bit more welcoming. There's plenty of people to carpool, so we can also take light rail and all that. So if you're like, where the heck is Redmond Town Center and whatever, you're welcome to carpool with me or any of the other members to get over there. And we'll generally try to make sure everybody has a way of getting home. And it's nice that we have light rail as an option now too. So that's great. All right. So when we get good recordings, when we've been wrestling with this system and looks like we have a fairly new system here, we post our meeting recordings on YouTube. And thank you to Carl for being our AV maestro for that. As always, there is a call for speakers. You do not need to be consider yourself a Rust expert in order to be a speaker. In fact, whenever we ask, generally about half the people in the room consider themselves to be Rust beginners. So if you feel like a beginner, note that half the room identifies with you. So having people speak by beginners, for beginners, to beginners is always a challenge because you can get a lot of advanced talks, but we don't want there to be a lot of imposter syndrome or people feeling like, oh, I could never do that. Maybe I can't do Rust. So it's important to make sure that we have good beginner participation as well. So if you have something that you'd like to talk about, something that you've done, happy to speak. If you have something that you are curious about, I would love to talk with you about it, because there's a way to give a presentation where you're leading a talk, and you're using this as a way to gain information, and it can still be very engaging with folks around the room. So if you're interested, let me know. We have a Discord server, which I missed. I should put that here. But on this QR code, we have a Discord server where you can interact with us between the meetings. And that's a great way to reach me. I'm also U007D on Discord. Okay. Zed is a company that's building an editor. They have a nice, interesting history and lineage with Electron and Atom, and other editors that you may have heard of in the past. ASM.js, which is a precursor to Wasm, Sublime. There's just an interesting history back there with Zed. They reached out and wanted to know if we would be interested in having them come to a talk, and so they were supposed to come speak today, but the organizer at Zed kind of had forgotten about it. And then when I reminded her, she was like, "Oh, expletive deleted. Let me see if there's a developer available." And there wasn't, unfortunately. So it looks like we are on track for next month, potentially. So, and they've also offered to give us their facility for the meeting, and they're in downtown Seattle. So, we've moved to this space and we're trying to keep it relatively consistent. But, now that we've settled here and it's working, if folks feel like it, we can certainly have a meeting over at their facility and change things up for a month. How do folks feel about having the Zed meeting at ZHQ? Does anyone love that idea? You like the idea? Sounds good? Yeah. Anyone that's a problem for is like, oh, that's going to be really bad to be in Seattle to do that? It'll work? Okay. All right. I just wanted to get a temperature on that before I said yes to moving the meeting. So I will confirm whether that is going to be June or July. For our June speakers, that's the next thing I'll do, is I'll talk to our June speakers and making sure that they're okay with getting bumped by a month. But if there's a problem there, we might reschedule Zed for July. So stay tuned for that. The latest information will be on our Discord channel. All right. Any news anyone would like to share from the Rust community specifically, or compute in general? Anybody heard anything cool and exciting?
There's been the thing in the news lately.
Yeah.
What's it called? The JS.
Bun. Yeah.
It's been in the news.
Okay. Yeah. Bun. Okay. Yeah. Do you want to talk about it? Do you want to talk about it?
Sure.
Okay. Go
Do you
for
want
it.
to come over here and talk in a microphone?
I can talk in a microphone.
Yeah. So the folks online can also hear.
Just go over there.
Yeah.
Okay.
Well, the bun. It's
Sit
a
down.
it's a TypeScript thing, right? Bun. I haven't used it personally, but I know that they did like a whole AI-based rewrite of Bun in 6 days or something, and they did a million line diff, and it was all completely automated by LLMs. And I know some people have opinions about it. I don't know. I don't know if I should share my personal opinion about it, but
Sure.
sure.
I mean, you just say, this is my personal opinion, and then you can share.
Yeah, my personal opinion is it's a bit janky, and it's probably not the right way to do it. I prefer like slower incremental ways of, like, if you're going to change programming language on your project, maybe not all at once, but what do other people think?
One other thing is Zig, the maintainer.
You can just repeat him.
Can I go over there?
I'll repeat.
The Zig maintainers also said that they do not want to use any kind of AI in the production of Zig, because they know they can make Zig happen a lot faster, but they want to do it properly and make it actually maintainable.
what he said was the Zig maintainers don't want to add any LLM code to Zig, the language itself. And I know that there was some conflict between the devs and the Zig, between the Bun devs and the Zig devs about that. I don't know if the idea is they want to change to Rust in order to now do lots of LLM contributions to the Rust programming language. We'll see.
So yeah, just so folks understand, Bun is package manager. Yeah, welcome. Come on in. Package manager, and I guess it's designed. I didn't realize it's a drop-in replacement for Node.js, but that's what it's for. So, so what's interesting about it is that was it written in Zig or rewritten into Zig? Is it started out in Zig?
And now it's Rust.
So they were in Zig and they decided they wanted to rewrite it in Rust. And then they decided, well, maybe at the same time, they decided that the rewrite in Rust was going to be done by AI.
So Anthropic bought.
Yeah, they're owned by an AI company.
That's right. So Rust has a reputation out there for being good, right, getting the job done, but it also has a reputation out there for being somewhat evangelistic and aggravating to people who aren't going to drink the Kool-Aid, and then to sort of rewrite a gazillion lines of code in Rust using AI is probably going to cause certain issues, and that's going to feed the fire. So it's just an interesting time to be alive, I guess. Let me just put it that way. My personal opinion, I share with you. I think this is not the way to do it. I don't think all AI code is bad code. There's a difference between slop and a code that's written carefully and code that is written by AI that is carefully reviewed and guided and shaped and constrained by humans. I think the problem for me is slop, and when you let the AI run loose, you get slop, at least in my experience, and I have looked into this at least a little bit. So that's my concern as well, is that we're actually gonna would I trust Bun? I don't know now.
Yeah, I saw online someone did an audit, and there were I think 13,000 instances of the unsafe word. I'm pretty new to Rust, so I'm shining some light on the implications of.
Oh my God!
No,
So there's 14,444, but that includes the unsafe in the comments. So I did like a really bad rep on it. So that's 14 raw, 14,444 raw unsafes. But then they had to do that in order to not fundamentally change the implementation because they were doing unsafe stuff in Zig. So to have the code be like one-to-one map, they had to do that much unsafe. There's also 5,000 free calls to unwrap, but that's not getting it like unwrapped work. So really basic grep for that. It passed, I think, 98.4% of tests in testing on the new implementation. And also they did not rewrite their JavaScript runtime. So they are still, they're still a wrapper. The weird thing about these, I use Dino. I love Dino. It's great. I highly recommend it. But what I get confused about sometimes is that they still have these C cores. Nobody's fundamentally rewritten the whole JavaScript runtime in Rust, so that's insanely safe and fast. So we're all arguing about tooling around a runtime that's still reliable. I don't know. Anyway.
Yeah. Okay. So between 13 and 14,000 uses of the unsafe word, whether some of that's in comments though. So, but certainly thousands of instances of unsafe in the source code potentially, and use of unwrap as well. Many thousands of instances of unwrap. So I think the question was, what's the ramification of that? A lot of people think that when you use the unsafe keyword in Rust, that you turn off the borrow checker, you can do what you want to do, and all is fine. That's not what it's actually for. Rust will enforce these memory safety guarantees for you, and this is why it's known as a strict language. So when you're writing your code, the borrow checker is beating up on you for not doing it right. When you write unsafe, what you're doing is you're saying to the compiler, what I am still upholding all of the same rules. that is required by the Rust language. It's just I'm doing it manually. You will not be able to verify that this is true. So you have to take it on faith that I'm doing it correctly. And if you mess up, you have undefined behavior, right? Anything can happen if you mess up. So what this does is rather than making your entire code base unsafe, right, where you could write whatever you want, you could write you could try to dereference a null pointer, you could write to memory you don't own anywhere. Rust makes that impossible unless you're using the keyword unsafe. And this means that you can focus your audits for safety and correctness very deeply on the code that is unsafe. But if you have 14,000 code blocks that are unsafe, you have a significant amount of code that's unsafe, and you are probably defeating the purpose of using a safe language. That's sort of the ramifications of that. Yes, comments?
Well, slop or not slop, safe or unsafe. As I understand it, under U.S. copyright law, their rewrite, because it's LLM generated, is not copyrightable. So take that for what it will.
So just under U.S. law, the AI generated code is not copyrightable. So there's another interesting ramification there. I think there's a hand here. Yes.
Is that me?
Yep. Go ahead, Jack.
So yeah, I think certainly the r/Rust community has sort of made this whole story a referendum on whether you think AI is good or bad, and everybody already knows what they think, so it's not like a super interesting question. I also work for an AI company now, so my opinion is totally irrelevant on that question. But I think there are other aspects of the story that would have been very interesting to us at a different time. So, for example, the guy who wrote Bun, who did this whole rewrite, the original author of Bun is the guy who's prompting Claude to do the whole rewrite. He has some tweets about the sort of issues in the Zig codebase that made him want to rewrite the whole thing, which is interesting. And it's a lot of the stuff that you might expect for someone coming from a systems programming language that's not memory safe and switching to Rust. It was stuff like, what did he say? So tired of fixing memory leaks and crashes and stability issues. Stability issues is like, as far as I know,
it's doing some heavy lifting.
Faults.
Yes.
Unsafe is really good way to get rid of that.
Well, and that I realize I'm going on too long to repeat it into the mic if it's not already picked up. But I think another interesting angle on that on the story is like, if you take a body of code, it could be that Claude is going to make it terrible. I don't know, but like if you let's assume it's machine translated and ignore the question of whether it was honestly translated. But you translate it from Zig to Rust, and the result is 13,000 blocks of unsafe. What that's telling you is that all the original code was also memory unsafe. It's just that it doesn't look as bad, in the other language. And so, like, sure, we shouldn't feel as good about it as we would feel if it was safe Rust, but like, I think it's an improvement, right? It's telling you something that was already true. It's not making the code worse. Now, it might also be making the code worse, but not for that reason.
I will argue. Let me try to summarize that really quickly. The author of Bun, who is prompting Claude to do this rewrite, is like has tweeted about his motivations, and he's found the code like he's so sick and tired of memory leaks and instability issues. So he's like, this was the impetus to even start this rewrite in the first place. I think the thing that Rust does with unsafe is you can build you should build safe abstractions on top of your unsafe code. So if you look at a primitive in the Rust standard library like vec, if you go deep enough, you'll find unsafe in there. But vec itself is safe. So you're like, wait a minute, how can I start with something that's unsafe and then sort of put something around it such that it's safe at that point? And string is built on vec, and so string is safe. And then whatever you might do on top of string is also safe. And so you can actually, done correctly, you can take a code base that is unsafe just about everywhere and design it such that you can compartmentalize your unsafety to at least some degree. And I think that is where Rust would have represented a win. That might have been too expensive. There might have been 1,000 reasons why they didn't want to do that. But when I think about the missed opportunity, that's what I think should happen.
The opportunity. I think they've just done phase one.
I hope so.
Which is the one-for-one translation.
Yeah.
And then now they can do phase two all in Rust.
I see.
Instead of switching between the two languages going forward.
Yeah, I hope so. All right. There are a couple other comments here. Yeah, go ahead.
Rust is just amazing if
Yes.
You
Yes.
just get to chat with it.
That's
and
right.
Oh, like open up, Command O, and you look at the compiler output, and you're like, well, that's not talking to me like that.
That's right. That's right.
I think also the unsafe is a little overblown because it's still only like 1% of the project. I think the bigger problem is that right now, literally nobody knows what is happening inside of the code. Like nobody has looked at a million lines of new code. We have this problem at work. We have some stuff that's totally generated that nobody looks at because the amount of money that would cost just for engineer time to review the code, way too much.
Right.
For stuff that's very low value and low risk.
Yeah.
And I think that's the thing long term we are more likely to see a problem with. At the same time, it's all an advertisement.
Sure.
They didn't spend anyone else's money on it. They spent a very effective and cheap advertisement for what it is. So.
Yeah. The comment was that it's a million lines of new code. Nobody's really looked at it. So, there could be a lot of problems lurking in there. How do you feel about test suites and how does that mitigate that risk in your mind?
It helps. I mean, especially if it's integration tests. I understand a lot of the tests that pass now are new Rust tests that were also written in the one shot, which I don't have any faith in. But also, I don't have worse than this. I don't use Bun. I don't use TypeScript at all, or at least so.
Yeah. Cool. All right. Two more. I saw two more hands. So we'll move on. Yes, sir.
Oh, yeah. I was just going to say, if this works out well, my opinion will have been all along that this was clearly a good idea. But if it doesn't work out, my opinion.
If this ends up not working out, my opinion all along was that this was a stupid idea. But if it does work out, then my opinion all along was that this was a great idea. I think that's a great comment. Thanks.
Failure is always an orphan.
That's cool. There was one hand over here. Yes, sir.
So I feel like AI slop isn't a problem if you have some sort of mechanism for verifying the code's correctness independently. So in Rust case, you have like the memory system, but you could have something stronger in principle that would verify the properties of the code that you actually care about.
Yeah. I mean, in some ways, I think the comment was that AI slop doesn't really matter unless if you have verified it for correctness with respect to the properties that you care about. And I actually think that might be, I don't like AI slop, so I'm very biased, right? But I think that might be tautologically true. So like I can't argue with that. Like if I define the things that I care about perfectly, and I verify that correctly, then AI slop doesn't bother me, I guess, because I'd have to include code size and code maintainability and code changeability and, anything I might care about, right? Whether it's expressiveness of the code, whether the abstractions are clean. I could just say I care about all of those things. So I guess that's tautological. I just think that in practice, very few people do that. And so in practice, AI slop can be a problem.
Yeah. One last thing. It's not quite tautological because you could have the AI generate the proof as well. Yeah, that is true.
Yeah.
Lean verify the proof, and then we just have to check our axioms.
Yeah.
I've done that a little bit.
All right. Well, anyway,
We've got one more.
Great. Oh, there's an online comment.
If it comes in, I'll read it.
All right.
Here it goes.
There's
Quick
maybe
announcement. The Bradbury, who's on the group, is also part of the Dallas Rust user group, which is on Meetup.
Hi, Dallas Rust user group.
So welcome.
Okay. Great.
They're looking at the book Deep Learning with Rust, Mastering Efficient and Safe Neural Networks with the Rust Ecosystem. So a book recommendation.
Okay. Yeah. Well, welcome, guys. That's great. All right. I think we'll just move on because we've got quite a bit of talks. And there's clearly going to be more conversation about this at the end, so that's great. All right. So tonight we have two talks. One is by Carl, 9 Ways to Get Inheritance in Rust Without Inheritance. And so, sorry, what was that? I know, right? I know. It's like all these hot, spicy takes here today, right? And I think that's fantastic. This is one of the things that I really love about the group is I hope that everybody feels safe to,
I didn't know it was going to be a problem.
Inheritance in Rust, in Rust, yeah. All right. Well, good. And then so our second talk is a statistical analysis of congestion control algorithms. I can't say that 5 times fast. So then it looks like, given the length of the talks, we'll have a bit of time, and we can chat more about Bun and AI and all things related to Rust and programming. All right, take it away, Carl. Do you want me to stop sharing?
Yes.
All right, I have to get to.
And hand me the HDMI also.
There you go. This thing is just. I cannot change tabs from that screen. I can't even see my tabs.
I want to do one trick. Watch this.
Am I not, did you just take over the sharing and I don't have to unshare?
Yes.
Perfect.
I took over the sharing.
Perfect.
And I hope you guys can see this. I hope people online can see it. If anyone in the room is online, make sure your speaker and microphone's not on. But it'd be good if you could tell me this is working. So I'm going to assume it's working. Today I'm going to talk about 9 ways to do inheritance in Rust, a language without inheritance. I'm Carl Cady. All the code is in GitHub, and the link is called Inherit. I'll put it on the Discord also. So first things, what do we mean by inheritance? If we're doing an object-oriented, class-based language, then we say a subtype can inherit stuff from a supertype, and the kind of stuff it can inherit is an interface. An interface, well, when 2 types implement the same interface, that means that we can use either one at a function that requires that interface. So they're substitutable. Another thing that a subtype can get from a supertype is code. If the supertype implements something, then the subtype will be able to call it. And finally, in some cases, if the supertype has fields, then the subtype will also inherit those fields. So Rust doesn't have class inheritance. That's certainly true, but it does have tools to get us the effects of the first 2. It has shared interfaces, and it has shared behavior. And we're going to look at those tools.
Is anyone else in the meeting? Because I can't see Carl's screen on it.
I am in the meeting, and I see Carl, but I also don't see your screen, Carl. Okay, that is a good point.
Make one more attempt.
I will see.
Start sharing. Share.
That looks better.
Okay.
Yep. Yeah, that's it.
Let me go over some definitions because I'm going to be a little loose with vocabulary. When I say interface, if you're familiar with languages like C#, that's equivalent to what C++ calls an abstract class. Those are roughly equivalent to what Rust calls a trait. And in all these cases, it's an interface, an abstract class. A trait is a contract or a role. It's not a structure, an enum that you can actually have a value for. A concrete class corresponds roughly to what Rust calls a structure, an enum. And this is a concrete type. It's something you can create and have values of. Hopefully that'll be made a little more clear at the end, or you just have to play with it to get these concepts in your head. My credentials. I've programmed professionally in C++ and in C#. I've programmed in Python, which normally wouldn't be a credential for this, but I programmed in Python with lots of classes. And my greatest claim to fame here is that I took a class in Smalltalk, one of the kind of most famous object-oriented languages, and I took it from Ralph Johnson, one of the authors of the Gang of Four design patterns book. So I should know what I'm talking about. We'll see. The format of this is that I'm going to have 9 puzzles, things that you might come across when you're programming in Rust that you need to solve. I'll present them first from a class point of view, and then we'll see code in Rust that will solve them. Discussion is welcome. I think I'm going to say I don't care if we don't get through all the slides. I'll just have a part 2 or whatever later. The one exception to that is I don't want us to try to define what object-oriented really means. It's too controversial. So here's the first problem we have. This is from a crate I have called range set blaze. So range set blaze is a data structure that holds, that represents sets of integers, like U8s. For it to do that, it needs, but it can work with different kinds of integers, so an I16 or whatever. For it to do that, it needs to be able to manipulate the integers, so it needs them to have functions like give me your min value, give me your max value. There's one it wants called create an exhausted range for this integer type. So if we look at that problem from an object-oriented point of view, we might create a class diagram like this. We have an abstract type integer that requires every integer thing to have a min value method, a max value method, and then maybe given those, it can define the exhausted range method for everybody who inherits from it. And then things that might inherit from it would be like our U8 integer, a concrete class, and it has to make sure it has U8 or min, max, and then it'll get exhausted range for free. And likewise for I16. So a quick question to the room, how would we make this happen in Rust? You can just yell out. Traits. And how do we get the exhausted range so we only implement it once?
Default implementation.
Default implementation. Just so. So we have a trait, we call it integer. We say an integer trait has to implement min value and max value, and it also has to implement exhausted range, but we'll actually give a default implementation. So you don't really have to implement exhausted range. You can get it for free. And then after that, we'll say to implement the integer trait for U8s, here's what you do. And you have a definition of the min value for a U8 and the max value for the U8. We don't have to do exhausted range. For I16, looks the same. And now we can use it. We can make R1 equal to an exhausted range of U8s, R2 an exhausted range of I16s, and then we can verify that R1 is equal to this this range that goes from 255 to 0 inclusive, which is the way Rust has ranges that don't have any values inside the range, empty ranges. And in fact, there's a method called empty range on ranges, and we can verify that R2 is indeed an empty range. So again, that's the trait default method. Good. Okay, I've got another crate called Device Envoy that helps simplify working with microcontrollers. One thing it wants to manipulate are servos. Servos are electric motors that you can say what angle you want the motor to turn to. So we want to be able to write programs that just use generic servos. And so what do we want those servos to do? Well, a servo has to have a set degrees method, maybe some other methods. And for our particular microcontroller, say our ESP32 family, we'll want a concrete type servo ESP that actually has a specific implementation of set degrees. But we also have this notion of a servo player, which is also abstract. And a servo player needs to be a servo, but it has additional methods. So say it has an animate method where we can move to a certain angle, wait an amount of time, move to another angle, wait a certain amount of time, and then maybe loop back and forth, animate. And then we'll have a different concrete class for that, servo player ESP, that will be, should do both those methods. So to the room, what's the concept that lets us set things up like this in Rust? Connor?
I mean, you could make servo player a trait that also requires you to implement servo.
Yes, so that's, whoops, I should probably move the microphone over to here. So that's super traits. So we'll have a trait servo that requires that we have set degrees. We'll have another trait called servo player that requires that we do everything that servo does. And it has this additional requirement that we implement animate. Now we can have, I've got a little kind of mocked up here, servo ESP. So it'll implement the servo interface for servo ESP. And in this case, I'm not really going to do hardware. I'm just going to print out a message. This actually surprised me when I was making this. I forgot how it worked. So servo player ESP is also a concrete thing that it needs to implement both servo and servo player interfaces. I'd forgotten that we need to have two different implementation segments here of code. So you say, here's how we implement servo for servo player ESP, set degrees does this, and here's how we implement animate. And here's some things that we'll pretend we're going through steps. Once we have that, we can write programs that are generic that work for any kind of servo. So center servo works with any kind of servo, and it sets the degrees to 90. Runwave works with any kind of servo player, and it calls the player.animate method on a particular set of times, angles and times. And once we've set this up, we can get what we want. We can say servo ESP lowercase is an instance of servo ESP. Servo player ESP lowercase is an instance of servo player default. And now we can call center servo on servo ESP, but we can also call it in servo player ESP. And we can call runwave on servo player ESP. What we can't do is call servo runwave on the regular servo ESP because it doesn't know how to do the animate. So good. We got that fancy diagram before, and now we've got it all in Rust. I should say we won't get to anything tricky till 5. This is just trying to understand every which way I could think of to do inheritance-like things in Rust. Problem 3, I think people will know this one. We want to add a new method, is odd, but we want to add it to an existing type that's outside of our control usize. So how do we do that?
Implement a new trait for usize.
Yes, which we call just by convention,
Extension.
which we call by convention an extension trait. So if we think of this in terms of object-orientedness, we'll have an abstract class, usize extensions, that requires is odd function to be defined, and then somehow we'll make usize be an instance of that. That's the only tricky thing, right? It's like this type already exists. How can we make it a subtype of some supertype that we've just defined ourselves? So let's see how to do that. Let me start by saying what doesn't work. If you don't, you would think that maybe you could just say, implement on usize a function called is odd, and you will get a compiler error that says you're not allowed to implement things on foreign types. In this case, it'll call it a primitive type. But you make this new trait, you say it's got the is odd, and now the Rust compiler is perfectly happy for you to implement the usize extensions trait on usize and give it a concrete method definition there. So this is extension traits. And when we do that, we can say, create a count of 7, and we can assert that count is odd and that it's not the case that 12 is odd. And that all works. One that's hopefully not too hard, I wouldn't think. We have an enum called LED level that has 2 values, on and off. We would like it to have a default value. We'd like it to be able to print debug strings. We'd like to be able to check the equality between two of them. We'd like to be able to put it into one of the standard hash tables. We'd like it to be clonable and copyable. How can we do that? You can just yell out. You could go through and implement all these traits. What's the most convenient way to do that? Yeah, so the most convenient way to do that, here's our enum, is to use this derive attribute. And that's giving us all this inheritance, what I think of as inheritance for free, derive, clone, copy, and so on. And once we've done that, it's got definitions. We can say LED default is our default level, on, off. We can check that the default level is off. We can check that on is not equal to off. For some reason, we've probably without really intending it, but we've decided that off is greater than on. And we can do some copying and cloning.
Question, Carl.
Yes, Brad.
Why do you think of derive, clone, copy, debug, etc. as inheritance? Can you expand on that a little?
Well, look at this slide. If you were coming from C++ and said, I want this thing to be a mix-in of all these types, I want it to be a mix-in of the hashable super type, then this is the way you would think about it. I think it's a good point, though, that just because maybe I have a tendency to think of things in terms of these hierarchies because of my background, that we'll start to notice that the Rust way of doing things not only doesn't have the hierarchies, but it's really only using a few building blocks. Like we called it, 2 examples back, we called it trait extensions, but we never used the word extension. As far as the compiler is concerned, that was just a trait. It's only by convention or by our convenience that we give it the name. It's no different than any other trait as far as the Rust compiler is concerned, which is nice. It means there's a few basic concepts here that are actually doing quite a bit of work, and maybe it'll make it easier to remember how to use it. Maybe you won't really have to remember 9 cases. Okay, this one I'm kind of proud of. We want HTML buffer to feel like a string for a lot of everyday method calls, but we still want it to be its own type. The trick here is that string is a concrete type with storage. It's not an abstract class interface, whatever. How can we have HTML buffer inherit from string type when string is a concrete class? I said how, not should. I said how, not should. Yes. Yes. We were going to see one of those traits. So yeah, Benny?
It's deref, right?
Yes, that's the one I'm going to show. I'm going to show deref. There's some other ones we'll list at the end. So this might be an evil thing to do, but it's really cool that you can do it, even if it's evil. So here's what you'd want to do. You'd want to say, oh, implement string for HTML buffer. And it's going to say, hey, string's a struct, not a trait. You can't do that. That's an error. So there's these traits called deref and deref mutable. And now we create an HTML buffer struct that has one field that's field 0 of type string. That's just the syntax we can use there. So far we haven't done everything here. Everyone will agree is something you should be doing. So HTML buffer now contains a string, and we're going to give it some of its own methods. We're going to say it's got a new method, and here's how we do the new method. Everyone thinks that's cool. Now we're going to implement this deref trait for HTML buffer, and we're going to say it's got a target type of string, and whenever you need to are asked to deref a reference to this HTML buffer, return the stuff at field 0, return the string itself, and likewise do the same thing for the mutable one. And now look what we can do. We can say page is a new HTML buffer page, and now we can say page dot push string, and we can just call the string method on our HTML buffer and push a string in there. And we can do it twice, and we can ask for its length. And we never define length. The reason length is there is because it's defined on on string. You can't do everything. I don't think you can test equality directly, but you can put an asterisk in front of your variable, and that's asking for the thing that page points to, and then you can put an ampersand in front of that, and that's say borrow the thing that you point to, and now you'll get the thing itself. Everyone agrees that deref is very good when it's used with smart pointers. So it's used with box and RC and ARC and so on. I don't think there's any controversy there. It's probably not a good idea to use it this way here, because the whole reason I wanted to create an HTML buffer instead of a string, because I could have just used string as a string type as my HTML buffer. The whole reason I gave it a new type was that if I got mixed up and put in the wrong thing, I would get a compiler error. And now I'm not going to get a compiler error in a lot of cases because I've made it because I've made it so permissive. There are some other traits that work in similar but not identical ways. If this is of interest to you, so you could look at the asref trait, the from trait, and the borrow trait. All do things that are a little bit similar to this. Puzzle 6. So range set blaze will hold a set of integers. We might have a whole collection of these sets and want to be able to do a union of them, like a vector of range set blazes, and we want to do the union of all of them or an array of them. If we look at that in terms of object-orientedness, we'd say, okay, a collection, we're going to call that an abstract class called iterable. A collection, I didn't quite write it down here right, but say it's a collection of, range sets specifically, well, that'll be iterable. I should say it only knows about range sets. I forgot to do that. And it knows how to do a union if we're given like 7 of these in a list, how to do the union. That's still abstract. But specifically, if we have a vector of range set of range sets, then we can get the union, or an array. That's all fine. That we could just do with the extension traits that we saw before. But we want it to work with any kind of collection, any, we'll say, iterable thing if we're doing this in Rust. How can we make it work with any iterable, even ones we haven't anticipated? Any keywords?
Type erasure.
What's that?
Type erasure.
Type erasure.
Type erasure. Maybe, I don't know. That's not the term I was looking for. So I'm going to look for the term a blanket implementation way down there. We'll see if that's the right term. So let's set this up first. I don't really want to bring in my whole range set blaze data structure. So we're going to make it so the only integer it knows about is U64s, and that it's really just a B tree set. We'll mock it up for this. And it knows how to create a new range set blaze, and we'll know how to create that's empty. We'll know how to get one from just a list of integers. We'll call that from slice. And we'll tell it how to do the union of 2 range set blazes, exactly 2. And we do that by going, in this case, going back to the B tree sets and doing the union and then collecting it all together. Oh, and we'll have a predicate, a function that returns a bool. Is it empty or not? So that's all set up. The next thing we can do is set up basically the same kind of extension trait we did before with a super trait. We can say we're going to define a trait range set collection. It's going to provide an implementation of union, but it requires that whatever it's being applied to can also do everything that into iter does, which is another type that says you can convert something into an iterator, and specifically an into iter of range set blaze. So if we do all this, then we could do range set extensions to like vector and array, and we could, for an array of these or a vector of these, we could do union. But we want to do more than that. We want it to work for every kind of collectional thing, every iterable thing, even ones we haven't anticipated. And the way we do that is what I'll call a blanket implementation. And the syntax is that we want to implement range set collection on a generic I, where I is anything that already implements the into iter with an item that's a reference to a range set blaze. And we'll see what you can do with that. So first we'll create 3 range set blazes, A, B, and C, and then we'll, just so we can check our work, we'll have anticipated what the union of A, B, and C should be. And then if you look at the next one, we can take a vector of A, B, and C, vector, and then say dot union on it, and we will get the range set blaze that is the union, and we can see that it's equal to expected, as expected. So that's good. And it works with an array, but it can even work with what I would consider strange iterators. So I was surprised when I found out that the Rust option object can be iterated. So we can create a sum of A, and then we can ask to iterate through all its values, which will only be 1. And anything that we iterate, we can filter, and then we can do some test to see whether we would like this or not. And even though this is a really weird type, it's a filter of an option, we can still call .union on it, and it'll compile because we did this blanket implementation. Here's one that I faced in range set blaze. I wanted to treat all 15 integer-like things uniformly. So that's what I'll call the numeric integers, U8, U size up to I128, but also the Unicode characters and the 2 IP address types. So for all these, because I want to be able to keep them in my set thing, I want to be able to maybe get the min and the max, and maybe I need to be able to add 1 to an integer or an integer-like thing. So in terms of a class diagram, we'd say we have an abstract integer, and then we have some kind of numeric integers. And for those, we have a way that we know about to add 1 and get a min value and a max value. And we also have Internet Protocol address integers, and maybe they have a different way than the numeric ones for adding 1 and for getting the min and the max, but maybe in common with themselves. And the Unicode characters will be off by themselves. And then we have specific concrete classes that would implement each of these. So if you had to do this, if you wanted to define these 3 methods on all 15 classes, what would you do?
Enum at outer level.
So the one idea is to use an enum. The thing here is we need to work with these existing types. These are all system types, so we can't create our own type that's U8, U16, and enum. Any other suggestions? Yeah.
Electrically, macros.
Sorry.
Macros?
Macros is what I'm going to use. I'm not confident now that it's the best solution, but it is the one I really used, and we'll talk about why I used it. So I'm going to use macros as suggested. So we have a trait, integer. It's got to be able to add 1, min value, and max value. And now with macros, you can do anything, right? So I'm going to make a macros just for my numeric types. And for that one, it'll say, oh, you can add 1 by just adding 1. There's a constant called min. There's a constant called max. So that's how we get our min and max value. That looks pretty good. For the IPs, we're going to pass in 2 types to the macro, the IP type and also its numeric representation type. And the way we add 1 is we convert it to its numeric representation, add 1 numerically, and then convert back to our IP type. Likewise, and then for min, since we know it's numerical representation, we can ask the numerical representation's min type and convert that into the IP type. So we're set. I don't know, since there's only 1 character type I'm working with, I needed to make a macro, but I did anyway. For Unicode characters, adding 1 is particularly tricky. We convert it to its numerical representation type, which is a U32. We add 1, But there's this range of U32s that aren't in the middle of Unicode that aren't allowed to be used. So if we find ourselves at the edge of that illegal, invalid range, then we skip over it and then convert whatever back into character. And then actually min value and max value are similar to the numeric, because unlike the IP types, character does have the min and max constants defined. And then we just do a whole bunch, we do 15 implements calling our macro. And I mean, there's a lot of different ways that you could arrange with macros. You could have had, anyway. And this is fine. And this is what I do in range set Blaze. So the question is, isn't there some trait that all these types already have? And the answer to that is no, but all 12 of the numeric ones do have a trait in a third-party crate called num traits, called primint, primitive integer. So why didn't I just use num traits primitive integer, and then I wouldn't have to do this macro stuff. I could just do an extension on primitive integer. And does anyone know why that doesn't work? So there's a problem with coherence, and specifically because the num traits crate is external to me, I don't know that in the future they're not going to add Unicode characters to it. And that means that if I've got an implementation for the numeric integers and say the character integer, and they're distinct, but in the future, who's ever controlling my definition of this primitive integer could put my character in there, and now we've got overlapping classes, which Rust doesn't like. Having said that, I could have just created my own primint type and just had 15 lines assigning it. And it would be about the same amount of code as using macros. So I don't know that using macros is better or worse than that. They're about the same amount of code. The thing I like about macros is when the going gets rough, you can always just use a macro. Just to show that this works, if X is the U8 254, then we can add 1, 255. If it's the Unicode character A, we can add 1. That's normally not allowed. I mean, add 1 isn't something you normally can do with characters, but we can do that now. And we can get the min value of characters, something that was defined, but we can also get the min values of the IP addresses, which there's no constant that defines those in the standard library, and now we've got it. Okay. Here's one that I didn't know you could do. So I've got this output array, and it's an array of Booleans of fixed length. So abstractly, we're going to consider this generic thing an abstract class, output array of size n, and we know how to create a new one that'll be set to all false, and we know how to set the level at a particular index position 0 to n-1 to either true or false. That's what the abstract class is. Our concrete class would be something like output array for a particular length, and we can use those two methods on it. But we also want output array when it's exactly length 8 to have yet another method defined called set from bits from a U8, where it goes through and takes all the bits of the U8. Does anyone know how we're allowed to do this?
Just use 2 different input blocks.
Yeah. Yeah, I had no idea that this worked. So the answer is we can, in general, you can have constraints when you do implementations, including having a specific constant set. So in general, output array is not a trait. It's a structure, a generic structure. So it's still kind of abstract. And in general, when n is just n, we define new and set level. But we can also have a second impl block that says specifically when it's 8, you can define this set from bits. And it works great. You can set 8 from bits, and it works. And it doesn't just have to be generics. I'll get to that in just a second so I don't lose my place. You can also have trait bounds. There's some lifetimes things you can do. You can have some combinations. Yes?
Yeah, so how do you have something like that not get called if your number isn't?
The compiler will say, I don't know what function you're trying to call. There's no such thing as set from bits on this thing, because this thing has to have a specific length by the time by the time you call it in the code. So
you have to go back and rewrite your code and not.
yeah. I mean, just like, right? I mean, you might have just said something blah blah and you've never defined blah blah. It's the same message you get. The compiler doesn't know where you got that name from. It thinks you're crazy that you'd even think that you could call that method.
Does it not give you a hint at all?
I don't know. I have no idea.
It tells you the method doesn't exist.
Yeah, I bet that's all, because it can't. Well, I don't know.
It does say that another implementation has that.
Oh, okay. So that's good. That'll let you go and see what's different. Puzzle 9 got a little small. For device envoy, I want to be able to write kind of arbitrary values to the flash memory. So each block of flash memory, 4K block of flash memory, is going to have a new and a clear method. But if I have a type that is serializable, I also want to be able to save and load that type into a flash block. But if I created a type that's not serializable, then you can't save and load into it. Where serializable is two traits or abstract classes on this slide, serialize and deserialize. So how would you go about having this work? Yes, I'm going to do it a different way. So that suggestion was to constrain an implementation to require these traits, which is this idea of what we saw in the previous slide. I'm going to do something different. We'll see what's bad and good about what I'm going to do instead. So first, let's set up something we might want to serialize is Wi-Fi credentials. Our flash block, I'm not going to do the whole flash stuff. I'm just going to make it a hash map from a key into a vector of bytes. And a flash block has an implementation of new and of clear that works all the time. No constraints. And in the same impl block, I'm going to define save, but save is only defined when the thing being saved implements the trait serialize and deserialize to an owned value, and likewise for load. And this does work pretty great. Let me just show you how it works, and then I'll show you how it works in a way that you might not expect and may or may not want. So we're going to create a new flash block. We'll create some credentials. And then we'll, to the flash block, save under the key word Wi-Fi our credentials. So they're saved. Now we're going to take that same flash memory, and we will load the things that we saved under the key Wi-Fi. It might, if it wasn't there, we'll get a none, but if it is there, we'll get some and our value of the credentials type. I'm just going to assume we got it, so we're going to unwrap and then verify that we got our types out of it. So that's great. Let's look what also works. In the same flash block that I've cleared, but nothing else, I can save a 42 as a U8 under the keyword number. Well, that's weird. I thought we were only going to be saving credentials in this flash block, but no, we can save anything in this flash block, any type that's serializable. And even worse, we can load number, but tell it we want to load a string. And this isn't a compiler error. This is fine. When you actually run this right now, you'll get a none value, because when it tries to deserialize 42, as a string, it'll tell that there's something going wrong there, and it turns the error into a none, but that's not guaranteed. It's possible that you, I don't know, wrote out an array of U8s and then asked for a U128, and it thinks that looks all fine, and it would just give you the wrong value. So in the case I'm really using this in Device Envoy, this is what I want, but along with saving the values, I also save some metadata, which is like the name of the type. So at least if you ask for a type with a different name than the type that was stored, it'll promise to give you back none. But that's still not like perfectly guaranteed to be type safe. If you wanted it to be more type safe, you can do what we saw before, which is for each block, make it work with only one type in particular. And that's just a choice you have to make, whether you want the semantics that your flash blocks can only save one type of thing or not. Okay, so this is the final slide. Let's just review what we saw. We saw we could have traits with default methods. We can add multiple levels of traits, like super traits, which let us have like our servo player that could act like a servo. We can have extension traits, which are really just traits that let us add methods to foreign types. When they're common things like clone and debug, there's a nice pre-built macros for us. If we want to be bad and inherit from a concrete type, we can kind of do it using deref. Maybe we shouldn't do that. When we want to make what I kind of think of as extension types, but for all things that would qualify, pass some test, not just the ones you anticipated, then you can do a blanket implementation that we saw before. When nothing else works, and especially if the number of things you want to work with is finite, in my case 15, you can just use macros to make your code as short as possible. With constants or even traits, you can gate an implementation block, so it only so these functions are only defined if the test passes, or even on the method level within an implementation, you can gate them so they only are defined when a particular test. And yeah, as I said at the beginning, what I thought was cool about this is I came into it thinking, oh, here's 9-ish different ways to do inheritance and whatever, and it's going to be hard to remember all the different Rust ways to do it. But there's really only a few concepts we've seen here. And the only things to me that are a little bit tricky is the things having to do with coherence and the rules that don't let you kind of do what you might want to do with a foreign function. And we see the workarounds for that. So any comments or discussion questions? Yeah.
Something I thought of at that last example where you can serialize as one format and then deserialize as a different one. If you wanted to constrain it so that each block could only serialize and deserialize one type, that'd be a good use case for phantom data, which is a type in the standard library, where you can actually store the generic type that you want to use inside that block. But it's not actually being stored, it's just the type name is being stored essentially.
Oh, okay. So Betty suggested that you could use phantom data to actually store the type, not like what I was doing, which was like some hash of the name of the type or something, and that it might be able to get you real true type checking. That's interesting.
It's zero sized as well.
Yeah, and if you did that, it would be zero size. It would just be stuff checked by the compiler.
Thank you, sir.
Oh, one more, and then we'll be done.
There's one other kind of inheritance you can do, which is even more cursed than some of the other ones you've done, which is use the any type and downcast.
Yes, I didn't even think of that. I'll have to
You're
look.
a bad influence.
I've never used it. I will look that up. Thank you. Oh, sorry, more?
I did, I was trying to can dynamically test something and have pointers to the dynamic types for the underlying type just to fill some amount of traits. I don't know if that would count though as.
Yeah,
I don't know if that would count in your slide set.
Right. I had to kind of limit what I was going to do. So the question or the comment was, there's also this notion, say you want to, I do something with audio clips in Device Envoy where an audio clip can be a compressed sound, an uncompressed sound, or it can be a tone that's just played algorithmically, or it can be silence. And I want to have an array of those. And you can't have a normal array of different types that all have different sizes, but you can if you use the dynamic types, which adds an indirection, very similar to what C++ does with its vtable stuff. What I like about Rust is I almost never have to do that, whereas my C++ was always doing it, apparently without really needing to. Maybe sometimes the compiler makes it go away. But in here, I only do it when I really do need to have a heterogeneous collection or something. And it turns out in a lot of my use cases, at least, I don't need that. And then everything is called directly with no indirection. So I guess it's faster.
That's type erasure.
Yeah, that's type erasure. Anything else? Okay, done. Thank you.
All right. 10-minute break, and then we'll have our next speaker come up.
Any opinions about the delegation RFC, Carl?
I don't know what that is.
I don't like it.
You don't like it, or you do like it? I have one. I mean, it's like, if you got some type foods got methods on it, make another type bar. It would be very nice if there was some syntax that's just like, bar just like has a food member, and all the food methods work on bar, and they just call them method. Like everyone wants this. I really want it. Every except
Of course,
except Brad.
of course.
Binary serialization would be so much easier.
Recording is on.
Every 15 seconds, it chooses a new path. It changes RTT and like delay. Sorry, RT is entirely the same thing. It changes is like, because like this satellite is going, your like RTT and like throughput and like all your configuration of a path will change. By not a lot, like relatively speaking, but like, yeah, absolutely correct. There are other complications here. The pacing is hard, and BBR ideally would love like microsecond granularity. It says milliseconds okay. Send quantum is basically their tricks to like send bigger packets, so like coalesce multiple packets into a bigger payload and send those out. That gets complicated. It's hard to get correct. A lot of bugs have been found in this area specifically. So when that doesn't work correctly, your assumptions about what you're sending are incorrect, and so the congestion control is like working out the wrong assumptions. And similarly with the pacing, like if you're delayed, your process library is delayed, your assumption is you want to send your packet every like 5 seconds, but like if you're getting delayed, you're actually sending your packet later, and so like your algorithm is inherently incorrect because it's assuming the wrong thing. So there's just like noise and errors that propagate and compound. So the key insight here is that the network's not deterministic. The process is not deterministic. And so your test run, when you try to run something and measure performance, is not going to be deterministic. And so how do we try to find that signal in the noise is by applying statistical analysis. And like the idea here is you have many, many, many runs, and then you look at the average, the mean, the statistical property of your connection simulation.
Question online came in from Mark. Have you looked into multipath, like 2 links cooperatively sending to one destination?
I mean, have I measured it or?
I'm just reading.
Yeah.
Have you looked into? It says. In other words, maybe is multipath a solution to any of the challenges that you're telling us about here?
Multipath, one thing sending to multiple, or two things. I mean, so the simplest case is like a single peer-to-peer. You can always make it more complicated. You can, there's something called a Dumble topology. So what I'm showing here is like partially Dumble topology. So you have NS1, namespace 1, server 1, client 2. So actually, maybe the two clients didn't do a single server is maybe what they're talking about. But you can have like two servers and like sort of you can model very interesting use cases here. You can have interleaving flows. You can have, sharing the same link. You can get as complicated as you want, I guess.
Maybe the question is about multipath TCP, using multipath TCP to carry the traffic. Then what happens?
I think depends if the paths are shared. So if there are different paths, then your congestion control will sort of be different. Yeah, because it's different paths. So one path could be overloaded, the other not. So the congestion control would be really based on the connection and / path. Yeah. So there's NS3, which is a network simulator. It's complicated to set up, and like it requires a additional thing you're running. And there's also like fancy like hardware simulators you can do to like do testing. My goal was to try and do this all virtually. So the idea is that you can spin it out very quickly in a single laptop, mimic what the network looks like, and then spin it down very quickly. And then you can use that to model very different, like interesting scenarios. And so TC is traffic control. It comes with Linux. And so there's a couple of things it provides. So what we're showing here is basically a network topology, a simulation topology. NS is a network, like a virtual network namespace. And you're basically creating a semi-Dumble topology where two clients are sending to a single server, and you have things like HTTP, NetM, FQ. FQ here is for pacing. You can also implement pacing in software. HTTP is for rate limiting, NetM is for delay and loss. So using that, you can essentially get very interesting scenarios. The code for what that actually looks like in code is here. And so the other interesting thing we want to look at is CDF. So a probability distribution, which is here, can be sort of, you sort of add up the probabilities and it ends up creating some graph like this. And so the scale of here is from 0 to 1. And so as you add up that probability, you can see sort of, I don't know how to describe it. You just have to like, statistics is hard. You take my word for it. It is a easier way to look at results. And actually we'll see how that makes it easier to see like what's happening with some simulation runs. And I found you need somewhere around like 100 runs, maybe a little bit less to get like a nice signal, especially on the long tails. Because if you don't have enough signals, the long tails are just like these random anomalies that don't really make sense. And so the pictures have been all of Bohr's because the library is called Bohr. I spent a lot of time picking out the pictures, so I'm proud of that. This link is missing. Cool. So this is also a single. Let's see if the demo works. This will be great. Yay, it worked. Can everyone see that? Okay.
No.
Yes?
Oh, can you increase the text size?
I can try. Let me start off. Yeah, okay. Cool. So what are we looking at here? Let me actually show you how to generate this. So I wrote the simulator part of this as a wrapper around the simulator and the test runs in Rust, and the viewer is AI coded, and like it used leptos and like trunk to like generate me pretty HTML. So I'm like really happy about that. But what I ran here was 100 runs for each of these scenarios. And the only thing I'm varying here is the delay between the two peers. So we go from 10 ms to 25, 50, 100, 200. And we're going to be looking at a couple of different metrics here. We're going to be looking at download duration, delivery rate, startup exit. Download duration simply is just how long it took to complete the download. Delivery rate is what are the speeds we ended up seeing on that network. I believe the top speed actually. And then startup exit, there's a concept in congestion control where we showed like it essentially ramps up very quickly until it hits loss, and then it like falls back down. That initial ramp up is called startup. And when it hits loss at that high value is called the exit. So when did we sort of hit that bottleneck of the link and like realize that we couldn't go any farther? And like that's a big determining factor of like the performance for the later part of the net connection. Because if you can get really, really high, really in the initial part of it, you're essentially like ramping up very quickly and then like at a high point. Versus like if you exit early, then you have to slowly explore what the actual link like true bandwidth is. I don't know if that made sense. So ideally, you would assume with zero loss, there's no loss here. You would always reach that like true point, but that's not always true because algorithms, all the non-determinism that can happen. Okay, so the thing I found really interesting about this is if you look at and so like you can see the red, like obviously it took longer. So, if we look at the tri-mean, let's just look at the mean. So if we look at the mean, you have, progressively longer times, and that makes sense because your delay is getting longer. And so you can't really tell from these like statistical values, like, hey, is that good or bad? It's probably okay. So if you look at the 10, the scale here is actually pretty tiny. So it's like pretty, it's a little unfortunate part about this graphing, I guess. So this is actually pretty good. Similarly here, these are all pretty good. What I find interesting is this last case. And this is still pretty tight, but like you have this really weird transitions that I can't explain. These are across 100 runs. And so there's something inherently weird in the algorithm that is causing this weird shape. And so right now it's probably okay.
Question.
Yeah.
The y-axis, that's like packets that have gone out and back to you?
The y-axis is probability here. Okay. So yeah, let's read this, right? So we're saying that 2% of all connections, so we ran 100 simulations, 20% of connections completed the download in 15.3 seconds.
Oh, I see. Yeah.
Whereas, the long tail, 90% of connections completed their download in 15.7 seconds. So it's a really nice visual, quick way to look at what the probability distribution looks like. Looking at like a PFD is going to be harder to see this pattern. So this raises questions of like, why is it doing that? And we haven't even introduced loss and other things here. The other interesting part I find is like, if you look at the 10 millisecond delay here, it's very tight on, so this is startup exit. So it's saying that you want bigger values. And we see that approximately 10% of connections exit at 16 megabytes, whereas other 90% exit. Sorry, there's a very long tail here as well. Where did this exit? Yeah, so I don't know why the long tail exists, but there's some clearly that are exiting. One connection looks like that exited really, really far up. But there's it's like a pretty tight band. You might be concerned of like why the 10% of connections are exiting slow like earlier, and that's something to look at. Like there's clearly something wrong here where the lower 10% is misbehaving and the algorithm's not behaving correctly. And again, this is like no loss, right? So you're trying to eliminate as much determinism as possible. A good testing framework, a good test should not have, should be very deterministic, right? So you can reproduce, you can have precise results and debuggability. So the idea here with this framework is to like remove non-determinism, and you're still getting 10% of connections exiting early.
They misbehaved and that made them faster, basically? Is that
No, they're slower. So they're exiting. So they're exiting. Yeah, this is startup exit. Yeah, and so if you look at the 200 millisecond delay, it's a much wider range of distribution.
So what in your simulation has non-determinism in it?
100% possible. Sorry, what's the question?
What could be causing non-determinism in your simulation if you have 0% packet loss?
Yeah, all the things I mentioned before. So
repeat the question.
Oh yeah, the question is like, what could be causing non-determinism in my simulation? And one, the algorithm's incorrect, right? And this would be the way to like investigate that. Two is you're still the simulation based on TC is not without pitfalls. You're doing networking over like local hosts, and the Linux kernel, when it does like stuff over loopback, it like cheats. It like, oh, I'm trying to copy from like, I'm trying to send from this link to the receive link, but since I'm on the same box, I'm just gonna like not actually send it over a link.
So
I'm just gonna copy paste it here.
So this is actually going through the kernel.
Yeah.
Okay.
So I've still not convinced the simulator is perfect. I think if you want to be perfect, you need to essentially set up a machine or like actual physical thing that can purely model the thing you're trying to work on or like simulate. But what are you gonna model, right? You're gonna model delays, you're gonna model bottlenecks, you're gonna model weird switches. So it's hard. So the idea behind this was to try to get good enough and actually explore, is it good enough, and like use that to quickly iterate and see like if you can find bugs. So that's non-determinism. You can still get non-determinism with just pure IO networking. If you assume the network simulator is correct, you've eliminated all of that noise. Yeah.
Can you just make like an extra network interface to the switch, and then it doesn't look to the Linux kernel, it is the same one? Let's just all go through the switch like as a repeater.
With switch.
Any
So
switch, your local switch.
yeah. So another idea was you could like do this in like namespacing in like on multiple machines on switches or just anything, and like is that what you were saying?
Just assign like your computer 192.168.01 and 02 instead of from 1 to 2. The Linux kernel doesn't know that it's doing that at that point. It is going over the network, but it's still
Got it. Yeah.
local.
I haven't explored that. I wonder if how complicated that would be, and like.
Just need to make another interface. You can make a virtual.
We should talk. You should talk. Yeah. Yeah. No. So yeah, if there's a ways to like get better predictability on non-determinism, I think that's probably key. I'm still not convinced this is all bad, but measuring stuff on loopback, it definitely has like its pitfalls, and like knowing what's correct and what's wrong is like not obvious. Very quickly.
Talk about the Rust stack that you use to build this.
Yeah, let's look at some code. So there's two parts of this project. There's a viewer, and then there's the simulator part. The dependency lists is actually not that like big. The simulator is mainly doing it's just a CLI. It's using Plotly library to do the graph generations. It's using Strat RS to do the statistical analysis, and that's really it. The main I guess power horse I would say is the Linux kernel here, NTC. And so there's a couple of scripts that and you can do this manually. You can like create the simulator manually. My idea was like, I have to run 100 different simulations, and I want to collect all these results, and I want to present them in a nice way. So I want to automate all that. So what the program actually does is call into just uses the command process struct to like basically call the bash script here, set up the network simulator, do a bunch of runs, collect the results, and then look at the output of the connection to like extract the values. So I think from a Rust perspective, what might be most interesting is the yeah. I have this generic like two stat metric, which basically is a trait. But the idea is that you sort of take the log output from the command. So you run a connection and like output some like statistical stats about like how long it took and remember the exit criteria, et cetera, et cetera. And you essentially just parse it and you store that as a value. The delivery rate was simple. The download duration was simple. The startup exit was a little bit more gnarly. Or was it one of these was more gnarly? But yeah, I mean, it from the Rust perspective, not super complicated code, but I think I found real power in taking a manual process, taking this like messy scripts and messy workflow, and then automating it, creating a quote unquote safe wrapper around this like really unsafe workflow and cumbersome workflow, and doing that in a repeatable way that allowed me to generate stats for these things really quickly. And I run a simple scenario, but I think that's basically the presentation if there are any questions.
So, is now a good time for a question?
Yeah.
So it sounded like a lot of the difficulty involved is just going through the kernel, and I'm curious, what's the downside of just trying to take that code out and like write a little game loop and not talk to anything, just like pretend that this vector is networking with this other vector?
One more time.
Why not just fake everything with a little game loop or something and pretend you have a network? Why go through the trouble of talking to the kernel and getting it to actually network for you? Does that make sense as a question?
Why? Sorry.
Like I could imagine saying that instead of configuring a kernel or even having a real network switch or whatever, you could just say like, all right, I've got these three routers and they're each like a hash table or something.
Yeah.
Like, it's got a buffer and I just have a manager and it says how much. Yeah, I just fake everything. Like, why not simulate it?
Where would you fake that? How would you fake that? Or
just talk about like a pure memory resident within your own.
Oh, within.
Yeah, like just like writing a game.
Got it.
Just cut out.
Network.
Yeah. Like using a discrete event simulator.
Yeah. So why not a discrete event simulator?
Why not do it fully just fake in process? Like,
yeah.
Abstract, slow down the clock, whatever.
Yeah. I think two reasons. So FQ pacing, you actually do need that piece. So there are implementations that use TCFQ to do their pacing.
What is TCFQ?
So if you have X number of bytes to send, you can send them all at the same time. If if they fit within your packet, or like you just basically slam the network and just send packets as quickly as possible. The idea behind pacing is that you actually sort of throttle your packets, and that throttling can be done in software. The pacing can be done in software, or you can use TCFQ, fair queue, stands for fair queuing. And so you send packets to the kernel, and the kernel will fair queue / pace the packets for you. So there's some implementations that require FQ for their pacing.
So you would have to replicate that in your.
You would at least need to replicate that or mimic that, or at least use it and then put it through your discrete server event simulator. And the other part is that I think you don't want to fully eliminate the non-determinism. It sounds
Throw in some random jitter or whatever.
Yeah. So like, how do you throw in that random jitter? Like dealing with loss, dealing with delay is a very real part of a network. And your algorithm, the job of the algorithm is to be able to deal with those things, to be able to deal with the delayed packets, to deal with lost packets. This is a very simple like delay. You can have very like interesting delay models where like every fifth packet is more delayed, or very interesting like loss models where like you have 90% loss, and like if you drop one. So actually, loss has an interesting property on the network. You typically don't see any loss until there's a burst of events where you see a significant loss. So you can model that sort of very interestingly in TC. Trying to model that and actually, so the place that I worked, we actually built something in a like a UDP forwarder thing in software to like sort of mimic TC. This was another attempt to sort of like get there. That is not a very convincing answer, and I don't know if anyone has like a really good way to measure these things. I will say that I think something like this, a simulator, is necessary to measure the congestion control algorithm, because trying to measure it in the real world, where you have a messy network, messy clients, interleaving flows, you can't really measure performance that way. You can't really tune performance that way. Yep.
Yeah, so a few years back, I forget who it was, I didn't look it up, it's in the Discord, but in Docker, people wanted to simulate packet loss and stuff like that. So what they did is I think they had like 2 Docker bridges, and you would have containers on one bridge, and then you would have a lossy router between the 2 bridges. And so that, I can look up the name of that project, but basically you could have your 2 separate PEs for your Docker containers, you could work your clients on each side, and then you can actually inject different amounts of loss.
Yeah. And that would theoretically get rid of your loopback issues, or like maybe more pure.
Predictable amounts of loss.
Yeah.
In between the 2 clients, so you can then see how it performs.
Yeah. I think that's a really good point. The nagging feeling that my simulator is incorrect because of loopback is like something I haven't been able to like brush off. And like exploring like a router switch or like a Docker thing, or multiple machines, like, is something worth looking into. Yeah.
Okay.
Yeah.
Thank you. Appreciate it. Take your HDMI. All right, everyone. Thank you very much for that. So we don't have to rush out of here, but just ask for, if we can put the room back together for City Hall. And then, again, for those who popped in a little bit late, we will get together at Red Robin, but we're not going to do the Overlake Red Robin this time. We're going to go all the way to Redmond Town Center and do Red Robin.